sums on this exercise 1.2. Find the LCM and HCF of the following pairs of integers and verify that LCM into HCF is equal to product of two numbers. That means, in simple words, we have to verify the fundamental theorem of arithmetic. Second sum, 510 is the first number and the second number is 12. Okay, so what to do? We'll take the first number and do prime factorization of 510. So factorize 510. So let us factorize 510. 510 is an even number, so we'll go on dividing it by 2. 255s are, now it is not divisible by 2. We'll divide it by 3. 385s are 255. Now again we'll divide by 5 because it is not divisible by 3. So 5 17s are and 17 1s are. Okay. Now what you got in this column, 2, 3, 5 and 17, these are all prime factors, and if you multiply all these numbers you will get back that 510. Okay, so besides this number 510, we will write it as a product of all the prime factors. So 2 into 3 into 5 into 17. Okay, now here all the numbers are there only once, so we cannot write it in powers, so leave it like this. Okay, next number is 12. So we'll take this 12 to the working column and factorize 12, or you can do it orally also. So 12, 2 6s are 12, 2 3s are 6, 3 1s are 3. Okay, so how we can write 12 as 2 into 2 into 3, or we can write it in powers straight away. It is 2 into 2 means 2 square into 3. Okay, now coming to HCF. HCF of 510 and 12. Okay, what is HCF? But before getting into HCF, HCF stands for highest common factor. Which are the common factors? If you see both the numbers, which are numbers present in both of them? Okay, you can see 2 in both of them, you can see 3 in both of them. So common factors are 2 and 3. Okay, now what is the least power of 2 and what is the least power of 3? Let us check. The least power of 2, you will see it in 1, that is 2 raised to 1, and the least power of 3 is 3 only. Okay, so least power of 2 is 2, which we see in the first number, and the least power of 3 also we see in the first number, which is 3 raised to 1. So HCF is nothing but product of common factors with least powers. Okay, with least power. So from the first number we get 2, and in the first number only we get the least power of 3 also, which is 3. So HCF of 510 and 12 is 2 into 3, which is equal to 6. And we write it how we got it, product of common factors raised to least power. Now coming to LCM, LCM of 510 and 12. LCM is product of all prime factors raised to the highest powers. All prime factors raised to the highest powers. The prime factors present here are 2, 3, 5 and 17. All the prime factors, product of all of them raised to highest powers. Okay, now if you see 2, what is the highest power of 2? The highest power of 2 is 2 square. Okay, what is the highest power of 3? It is 3 raised to 1, which is 3. What is the highest power of 5? It is 5 raised to 1. And what is the highest power of 17 present here? It is only 17. So LCM is nothing but the product of all prime factors raised to the highest powers. So it will be 2 square into 3 into 5 into 17. Okay, and if you multiply all this, 2 square is 4, 3s are 12 into 5 into 17. If you multiply all these numbers, you will get 1020. Okay, now verification of the statement LCM into HCF is product of two numbers. Okay, so let us verify. LCM into HCF is equals to what? LCM into HCF is, LCM is 1020 into HCF is 6, is equals to, we get 6120, and product of the two numbers, the numbers are 510 and 12. So 510 into 12, that also if you multiply you will get 6120. So what we can say, LCM into HCF is equals to product of the two numbers, hence we have verified. Okay, let us move on to the next problem. The same question, verifying the relation that we have, 336 and 54. Okay, so let us take the first number 336 and do the prime factorization of 336. So factorize 336. If you factorize 336, you will get 2 168s are 336, then 2 84s are, then 2 42s are, then 2 21s are, now 2 won't divide, 3, 7s are, and last is 7 1s are. Okay. Now how many 2s we have? 1, 2, 3, 4, 4 2s, 2, 2, 2, 2, then 3 and 7. So let us write it as 2 raised to 4. Since 4 2s are there, 2 raised to 4 into 3 into 7. Okay. So 336 is factorized. The next number is 54. So let us factorize 54. So if we factorize 54, it is 2, 27s are 3, 9s are 3, 3s are, and 3 1s are. Okay. Now if you factorize 54, you get all these numbers. So if you write it in powers, it will be 2 into 3 cube. There are 3 3s, so it will be 3 cube, right? So we wrote the numbers in powers. Now let us write HCF. HCF of 336 and 54 is equal to product of common factors raised to least powers. Okay. So which are the common factors? Which are the common factors? The common factors, if you compare these two numbers, are 2 and you can see 3. So 2 and 3 are the common factors. Now what is the least power of 2 and least power of 3? The least power of 2, you will see it in the second number, 54, that is 2. And the least power of 3, you will see it in the first number, which is 3. The least power of 2 is 2 and the least power of 3 is 3. Okay. So HCF of 336 and 54 is 2 into 3 is equals to 6. Product of common factors raised to least powers, HCF we got. And next line we write LCM. LCM of 336 and 54. LCM is product of all prime factors raised to highest powers. The prime factors present here are 2, 3 and 7. All of them raised to highest powers. Now what is the highest power of 2? The highest power of 2 is 2 raised to 4. So let us take it. The highest power of 3 is 3 raised to 3. So let us take that also. And the highest power of 7 is only 1, that is 7 raised to 1. So let us multiply all this, 2 raised to 4 into 3 raised to 3 into 7 raised to 1. 2 raised to 4 into 3 raised to 3 into 7 raised to 1. If you multiply all these numbers, we will get 3024. Now let us verify the statement. LCM into HCF is equals to 3024 into 6. If you multiply them, you will get 18144. Okay. And if you multiply the two numbers, 336 and 54 also, if you multiply, you will get the same 18144. So what we have done, LCM into HCF is equals to product of two numbers. The fundamental theorem of arithmetic is verified.